So number 4 is a topic on organic reaction. For the following reaction, identify the reaction type. The reaction type start with essentially identifying the functional groups. So we are seeing here is a double bond with a hydrogen, right? So it is an alkene and a hydrogen. And this is what we call the hydrogenation. Sometimes people call saturation of double bond, okay? Hydrogenation of double bonds. Okay. And so what's the product of the A at the end? So we can see that 1, 2, 3, 4, and then this is a carbon here, and then all the bonds are saturated, so now CH, and this is an H, and CH3, CH2, CH3. Okay, so this is a final product as a result of the hydrogenation reaction. So let's look at the number 2, and then I see the alcohol here, and I see the HCl. And there are two stages of this reaction looking for. The first stage is actually this. Let me just write it this one first. Okay, so let's write that as alcohol with HCl. And the first step that is going to be happening here is actually protonation of OH, and so that's essentially acid base reaction. Yeah, alcohol acid base reaction. And then once this is done, and then you will have this OH is being replaced by the chlorine. Okay, so then we'll have substitution. So it's actually a little complicated mechanism, and I need to explain it to you in the bottom. But let's just it's a good idea to identify the functional groups, and then this alcohol, which has a OH group. This OH group is replaced by the chlorine shown up here. So OH is substituted by chlorine. Okay, so you are changing the partners. So let me explain this how the reaction occurs. And this one is essentially 1, 2, 3, 4 carbons with an OH here, and then HCl. And because this is an acid, and that's a base which has a lone pairs, what's going to happen is 1, 2, 3, 4, and they will have a protonation with developing the charge here, and then chlorine minus. Okay, so this is an acid base reaction. But once you have this one, and that's what I mentioned here above, acid-base reaction. Okay. But once you have this, what's going to happen is this one has a lone pairs, and this carbon connected to here, and this is experiencing the partial positive charges, because this is a good leaving group. They want to be a neutral water, so what they're going to have it is, okay, this carbon is attracted by this negative charged chlorine ions, and having this water to be leaving in here. Okay, so as a consequences, what you're going to have is these 4 carbons, and then you have a chlorine being attached, and you have an H2O as a leaving group. So this is your product. And as far as the before and after scenario, this 4-carbon butane with an OH at the end has a product with chlorine at the OH at the end, and leaving the waters as a side products on here. And so that's why when you have a alcohol with the HCl, and the final product is essentially substitution. It's a substitute, right? Essentially, OH is substituted by chlorine. So that's why we call it substitution reaction. Okay, let's move on to the third one, and this is also once more identifying. Okay, this is an acid, and this is an alcohol. We know that this is one of the common reaction that we discuss, which is acid plus alcohol. That means ester plus water. Okay, so and this is happening the same way that I explained it before, and you will learn more deeper when you go to the organic chemistry taking in your second year. So there's a lone pair, and this one is going to make a bonding, and then this one is a leaving group as a water, and so what you're losing is H2O from here, and you essentially, in a way, the OH is replaced by this alcohol, right, from the acid group. And so your final product for the C is, so let's just count the number 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. And then the 1, 2, 3, the third one has a methyl group here. And then this one is a CO. Okay, so CO. Double bond. And then has a, we choose a different color. Right? O with CH2CH3. Right? And then you have a H2O water. And then you can finish the rest like this. CH3, this is all H and CH2. Okay, so you can write it as that's esterification reaction. Okay, so this is very specific. More generic name, there is actually also coming out from here, which is, and this is a common word that this water is coming out as a byproduct, and this is a small, what we call the condensate. Okay, so it's called a condensation reaction. Because think about when you have a cup of ice, right? Ice cup, the waters are kind of dripping on the water condensate. It's happening on the wall, on the wall. So this is a condensation, has a meaning the small molecules are being formed as a part of the byproducts, and then this is an example of condensation reaction. The number D is actually kind of redundant to the number B shown up here. As you can see here, this is an amine and HCl. So what's going to happen is a lone pairs. So this one is an H plus and Cl minus. They simply go to acid base reaction. Okay. So for the number D, so your product for this one is now they are being simply this is called the amine acid base reaction. So with this organic chemical reaction is to identify the major products. So this one is now amine. What used to be here CH2, CH3, and hydrogen. And then this is a CH3, CH2, 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 right? So those are the 4 carbons that, oh, we used to have just 2 carbons. I don't know what happened here. Sorry about that. So this is a CH3. So these are the carbons attached, and there's a hydrogen attached, and this one. Now this one is now being attached by proton, and because of that they develop the formal charges, and the chlorine minus is shown up here. So that's a result of acid-base reaction when you're having react with amine and an acid, right? So this is an amine plus acid, and you have an acid-base reaction. Thank you for your attention.